Okay, so welcome to Module 6, Lesson 4, one last time, solving for unknown angles using equations. Okay, so here we go again. Let's get started. Okay, so our opening exercise here opens up a little bit differently. There is no actual diagram of an angle situation. There is only these statements right here. So the complement of an angle is 4 times the measurement of the angle. Find the measurement of the angle and its complement. Okay, so this is not so very different from some activities we did a long time ago. Some of you will remember that. Handed you out a sheet of situations such as this, and you had to go ahead and actually, firstly, of course, put together an equation. Okay, come up with your equation based on what you see here. So let me go ahead and have you pause and see if you can work this out together using, of course, your knowledge of terms such as complement. Okay, all right, and of course 4 times. Okay, these are some key terms and words you'll need to pay attention to. So go ahead and give that a whirl. Okay, so here we go. Again, paying attention to complement. What does that complement mean? Well, that means there's going to be 90 degrees total that we're going to be talking about, okay? And that complement of an angle is going to be our x, okay? The angle, because this is what's being compared to when you're putting together or you're building an equation, okay? You have to find, at times you'll find one of those that stands for the singular variable. In this case is of an angle right there, so an angle x. And then we have another one because the complement of that angle, okay, the complement of angle x is going to be 4 times the measurement, okay, 4 times the measurement, therefore it is 4x, okay. And if we put these together, we'll come up with the equation x plus 4x equals 90, because these two angles are complements of each other, which is told to us right there. Okay, then we continue. 5x equals 90, and the inverse, multiplicative inverse, and then we have x equals 18 degrees, so that x is the measurement of that angle. Okay, so that's one of those complementary angles, and then the other one we figure out by multiplying that 18, or that x, times 4, which is right over here. Okay, so we have 72 and 18, and they do equal 90, and therefore they are complements of each other. All right, here we go. So I want to just throw you to the dogs here. This one looks pretty brutal, but it's not. So go ahead and find the measurement of FAE, angle FAE, and angle CAD. And here they are. Here is FAE, and then CAD. Okay, so that is your task right now. Any which way you can, go ahead and use relevant angle relationships to make your way to the solution for those two. All right, go ahead and come back and we'll check it together. Okay, boy oh boy, I tell you, this is, I hope you are feeling empowered by your knowledge, because I sure do feel that. There are really so many different ways that we could do this. Well, I realized I could do this with this newfound knowledge. Well, not exactly newfound knowledge for me, but newfound knowledge for you. Okay. Well, let's just go ahead and I'll show you how, one of the ways I did it. Well, what I did notice, okay, and I noticed some things here. I did notice that these two angles here are vertical, okay. So what that tells me about those two angles there is that they are equal, okay. So what I figured, if they are equal, what that has to tell me is that these two are also equal, okay. These two are also equal right there, okay. So you see that one, there's angle A, and there is this other angle here, angle whatever, okay? Because they are also vertical, okay? And I don't know if that's difficult to see, but if you see again, here's that angle GAB, and then FAC, okay, right there and there. They're also equal, which is nice. I mean, if I use that right away, it's pretty easy, because what I already have the measurement for A, okay? And what I do have for the other angle here is I have 2x, I have 6x over here. There's my 2x, there's my 6x, because that angle is made up of 2x plus 6x plus, of course, there's my hint there, 90, okay? All of that is going to equal up to 170, because this angle here, all of those together are going to be vertical to this 170 degree angle there. All right, and therefore it's real easy. I combine my 8x plus 90 equals 170. 8x equals 80. Okay, because I've subtracted away my 90 from each side. All right, and then of course I have x equals 10. Okay, so x equals 10 degrees. All right. And of course, that wasn't the question that was asked. It wasn't to solve for x, but I needed to solve for x before I went and solved the true problems at hand, angle FAE and CAD. And of course, FAE right here was valued at 2x, therefore it is 20 degrees. CAD had a value there of 6x, and therefore it is 60 degrees. Okay? And then if 20 plus 60 is 80, plus another 90 right here is indeed 170. Okay? So yeah, that's one way I did it. That's the way I finally did it. What I was thinking, though, is to look at just a different way. There are other... Well, maybe I should just erase this instead of going backwards. So, and again, I'm not going to do it. I just wanted just to show you, and I'm not sure which way you did it. But, you know, we also know that everything together is going to equal 360. So we could have done something like actually solved for these two vertical angles here and here, because we know 170. We could have done 170 plus we had 90. Okay, and then we had 2x and then 6x. Okay, and then we had these other two unknowns, so those are actually both the same. Okay, so that could be plus another 2, plus, well, actually we could just do that first if we did. Okay, so if we did, then we would have to say, oh, here's what we would do. I'm sorry to be thinking out loud here. We could actually do 360 minus all of that. See where I'm going with this? 2x plus 6x, okay, minus all that, and then should equal 0. Okay, no, should equal, well, whatever this does equal is going to be actually equal these here. Okay, it's going to equal the value of these two together, and then all we'd have to do is divide those by 2 to get the value of those, and then we could, from there, we could solve for x. I know that sounds pretty crazy, but anyway. All right, here we go. Let's go to the next one. Two lines meet at a point. Okay, now they're getting back into that. Relative angle relationships. This is pretty much the same old, same old. Set up and solve an equation to find the value of x, and then find the measurement of one of the vertical angles. Okay, this sounds an awful lot like, or is exactly like, some problems, the problems we did from last lesson, lesson 3. Okay, so go ahead and give that a whirl. If you remember, flip back to give your memory a little nudge there, and come on back and we'll look at it together. Okay, so again, you could have used a protractor, like I had mentioned before. in last lesson, but I went ahead and went through that similar process. That one right there, just splitting those two angles up into their respective x's. Okay, since I know that is 3x, I can split it up into 3 parts, that angle on the left. And then the other, I just split the one up because I want to separate that out from between 64 degrees and the x that is included there. Okay, so all of those little bits there have the value of x. Okay, and then those two right there, those two angles are vertical angles. Okay, so therefore they are equal to each other. So I can set my equation up to look like that, and then solve it very simply. X equals 32. So each x is 32 degrees. Each section of x. Oops, darn. Just go back there. Okay, so then we're gonna So that's right. X equals 32, and then we are going to the measure of the vertical angles. Well, we could just go ahead if we went ahead and looked at these vertical angles here. Then, if we looked at so we figure out these two vertical angles here. We know that since this whole thing is worth 3x, we know that it is going to be times 3, so that's going to be what, 90, is that 96? Yeah, 96 degrees. And then this would be 64 plus an x, so 64 plus 32, of course, is 96 as well. Okay? And again, if we wanted to, we could figure out the value of these, but I don't feel like it. All right, so let's go ahead and move on to exercise 1. Set up and solve an equation to find the value of x. Yada, yada, yada. Okay, this is the exact same thing. Okay, go ahead, give it a whirl. Good luck. Okay, so I'm going to use the same strategy I used for this one here and last lesson, but I don't need to. I'm getting to the point here. I don't really need to draw all those 5 different lines on that one angle there to separate that 5x into 5 pieces. It's really just important for me to actually separate out that 1x on that bottom angle there, if you notice right here. So now I've crossed out my x down there. So now what I'm left with here is I've just taken these two x's out of the picture. Okay, because I'm going to go ahead and compare those two vertical angles that I've created right there. Okay, so I've created those vertical angles there, and I know that that equation is 4x equals 132, and if I divide 132 by 4, which is really what I'm doing, I get x equals 33. Okay, so I've solved for x. If I want to go ahead and solve for those those two vertical angles. Okay, so I went ahead and solved this similarly, in a similar fashion to this one, but I did one thing a little bit different. I just went ahead and added one line there. I just wanted to separate out the x on one x on both sides. You see that I didn't need to separate that 5x into 5 different pieces. It really wasn't necessary. Because all I'm trying to do is I'm trying to get rid of that x on the one side, which is truly what I'm trying to do. In truth, I could do this all with an equation as well. But anyway, it gets me down to the fact that I am going to compare now those two vertical angles I've created, which looks like this now, 4x equals 132. And if I go ahead and complete that, divide 132 by 4, I get x equals 33. Okay, so I have x equals 33. And so if I want to go ahead and solve for the two vertical angles, all I have to do now is plug in my x. Okay, so 5x, 5 times 33 is actually 165. And then plugging 33 in for x here, 133 plus 132, of course, is 165 as well. And that's the value, the measurement of those two vertical angles right there. Okay, so here we go, example 2, 3 lines meet at a point. Ooh, looks like lines at a point. Anyway, list the relevant angle relationships, set up and solve equations to find the value of b. All right, go for it. And as always, there are probably many different ways to do this, and you guys may have figured that out already. But probably a pretty simple one here because we know that all of these, since these are angles, three lines meet at a point. But what you do notice here, these are all straight lines. So that's great. So what this line does here is it kind of separates this into 180 degrees here, of course, and 180 degrees here. All right. So that's pretty simple, because therefore all we would need to do is then we know that these two lines are vertical, okay, and they are equal. All right. So we're going to solve for B. We just need to find out what this unknown angle here is. Okay. So we can call it. We could just call it C degrees if we wanted to. We could say that C equals 90. I'm sorry, not 90, but 180 minus 37 plus 43. Okay, because we have to. That's going to be whatever's left over is going to be the value of C. Okay, so therefore we have C equals 180 minus 80. So that's 100. Okay, so we know C is 100, and if C is 100 and B sits vertical to it, it's going to be 100 degrees as well. Okay? All right, so this one is in terms of relevant angle relationships. We're probably looking at angles on a line, okay? Not only angles on a line, but also, we had to use vertical angles as well. All right, okie doke. That was pretty easy, huh? Wow, just a lot of practice, I guess, we're getting here. So, exercise 2. Two lines meet at the common vertex of two rays. List relevant angle relationships and set up and solve an equation, again, to solve for B. And again, first thing you want to do, I won't do it for you, is to recognize where the lines are, where the rays are. And it's not that difficult if you just look real closely at the directionality of the lines. So go ahead and do that and come on back. Okay, so I think the key point here for me was just looking at this idea of two lines meeting at the common vertex of two rays. So two lines meeting. Okay, so whenever two lines meet. And again, let's go ahead and identify what the lines are. These are the lines right here, this one and that one. Okay, and you can see that because you can see how they move straight, whereas these these rays are not moving straight. Okay, really important, because what two lines do, where they meet, they create, and you probably know this already by now, they create two pairs of vertical angles. All right. So, what I went ahead and did, therefore, was to look at those two, and I'll show you the vertical angles. So something else I could look at right now is I can know that that is 90 degrees, all right, because of my box. And then I can go ahead and take those two vertical angles, and here they are. Here's the one right there, okay, and then this one right there, okay. So I know they're equal. Okay, they're equal because they're vertical, and again, this is my angle here, and then angle there. Those are equal. And what I do know about this side is I have the complete angle already, and that's 90 plus 80. All right, so that equals 170. So what I know then, therefore, is that B plus 95 is the same as or equals 170, okay, because I've already added those two. I could have put 90 plus 80 if I wanted to, but I didn't want to. So we have that, and we can go ahead and solve from there. So then we have B equals, and again I'm subtracting 95 away on this side, and what is that? That is 70, 75. So B equals 75 degrees, all right? And so there we go. So I guess again, the relevant relationship or relevant line angle relationship was my vertical angles. And if you remember how we use our shorthand for that, vertical angles. Okay. All right, here come some more of these that I love so much. All right. Ooh, we have a fraction. The measurement of an angle is 2/3 the measure of its supplement. Find the measurement of the angle. Okay, and I would recommend, if you want to, use a tape diagram if you want to help you out, just to suggest that. But you don't have to, of course. You could just go ahead and work this out. 2/3 is sometimes a little bit dodgy to work with, but go ahead and try to set this equation up and solve. If you're having difficulty, of course, just come on back. But I'd like you to pause and give it a whirl first. Okay, so in setting this one up, a little bit different than what we've done in the past, I guess. Kind of similar, kind of different. So now we have the measurement of an angle. Now, that may seem like that is going to be our x, but if you look at here, is 2/3 the measurement of its supplement? So in this case, that supplement is actually going to be our, we could use it as our x, for example. So we would do x, the supplement. Okay, so if we put, let's just write these down anyway. So here we have, what we're doing is we're taking the supplement, okay, and then we are adding 2/3 of that angle, okay, and that of course is going to equal 180, because when we're talking supplementary, we are always thinking immediately of 180 degrees, okay. Of course, a supplement is not 180, but when we think of supplementary angles, okay. And again, we're just going to go ahead and put, use, of course, variables here. We could do x plus 2/3 x equals 180, okay. And then we can continue, and so we have 1 2/3 x, right? But much easier to put 4/3 x, and we all know why. Hopefully we know why. We'll remember why from way back when, okay? Using improper fractions, much easier to solve for than mixed numbers, okay? So again, 4/3 x equals 180. You guys have got this dialed in. I am certain, many of you. We just go ahead and then multiply by the multiplicative inverse both sides. And if we do, we get, of course, x equals... Okay, well, maybe some of you might have noticed that I did something wrong there. And it was just driving me crazy because it didn't seem like it was going to work out. So the way I thought it would work out. But you see, what I did is I had changed 1 2/3 into 4/3 originally. But now you can say I've corrected that, and that would be, of course, 5/3, because 3/3 plus 2/3 is 5/3. All right, so I've just changed my my denominator here, right here, to be 3/5, and this would be, of course, 3/5 there. All right, so we have x equals 540 over 5, because I multiplied 180 times 3, and then 1 times 5, so 540 over 5, which equals 108. Okay, so the measurement of that supplement now, and that's what we solved for, because that was our x, is 108 degrees. And of course, if we have the other angle, which is 2/3 of it, okay, and its supplement, all right, so the supplement of 108 degree angle, of course, all we have to do is take 180, subtract away the 108, and we get the other angle, which is 72 degrees. Okay, so in this original problem, we have the measurement of an angle. So this angle they're referring to is actually the 72 degree angle, and then its supplement is that 108 degree angle. Okay. All right, so off to the next one here. Let's give it a whirl. The measurement of an angle is 1/4 the measurement of its complement. All right, find the measurement of the angle. All right, so yeah, so just keep in mind what complement means, okay, and go ahead and solve this on your own. Okay, so here we go. Let's look at a few key things here. All right, so oh, I did that way too fast. I didn't mean to do all that so quickly, but let me go over it again. All right, so we're looking at the measurement of an angle. Okay, an angle is 1/4 the measurement of its complement. Okay, so because the complement is being compared to, okay, we're comparing to the complement, that complement is going to be our x, as you can see there. And then we're going to add 1/4 x because this angle is 1/4 of its measurement, 1/4 x, and of course it's going to equal what? What did you put it to equal? Well, if you remember that complementary angles sum to 90 degrees, those two would equal 90. Okay, so x plus 1/4 x equals 90. And again, 5/4 x, that's adding, of course, this x, which is 4/4, plus 1/4 is 5/4 equals 90. And multiply by the multiplicative inverse, and we get x equals 360 over 5, which equals 72 degrees. So x equals 72 degrees. Now that x, of course, is the complement that they're referring to, but they wanted us to figure out the measurement of the angle, that original angle they were talking about. Therefore, we just take that 72 away from 90, and we're left with 18 degrees, which is the measurement of the angle. Okay, so here we are. We are at the last example and exercise before we close this lesson, and we are doing this in quite speedy fashion. All right, so 3 lines meet at the common vertex of a ray. Okay, list the relevant angle relationships, set up and solve the equation to find the value of z, or as it's known in Britain and Australia and other places in the British Commonwealth, Z. Okay, here we go. Go ahead and do that, and come on back. Okay, well, as I've been saying constantly, this is there are so many different ways to come to the answer to several of these problems. Here is just one way, and as I was doing it, it felt like, I don't know, I had this sense that there must have been a more efficient and quicker way to do it, and maybe you found that. But anyway, here's how I did it. Okay, so I realized right there that's 90 degrees. Okay, that 90-degree angle right there. And then that is not z, okay, or z, because z is actually that whole, see that whole little semicircle type thing right there. That. You always have to pay attention to that, because sometimes they put z right there, and or put the variable and with the degrees notation right there, and it looks like they're talking about just that one angle in which it exists or which it sits, but it's not truly that. It is actually that larger angle, and hopefully that did not go unnoticed. All right. So therefore, I know that across there, across from it, sits a vertical angle. So I know that those two angles together there are going to equal up to 90. Therefore, I know that that other angle is 61. Okay, so here's what I have presently. Okay, I have 61, 29, and Z. Okay, and I know that entire angle right there, that where that 61 sits in right here, is 90 degrees. Okay, therefore I know the angle next to it, its complement. Okay, I used a complementary angle here, is 29 degrees. All right, so I'm getting there. Now I also know that these are angles on a line. Okay, right there you can see I have my angles on a line. All 4 of these right here, this and this and this and this, are all going to equal 180 degrees. Therefore, I added up 29, 61, and 29, and that was my 119. Subtracted away, and now I know this angle over here is now 61 as well. All right. So here's what I have. Now I'm at this point. I have all of those. Now what can I do here from here? Probably several things, but here's what I did. I went ahead and noticed that those 2 lines intersecting created 2 vertical angles. All right, and you can see that that vertical angle includes 61, 29, and 61. Okay, and that equals up to 151. And if you notice again, let me just draw that again. Here is that one angle right there. Okay, this one angle here is going to be the same as its vertical angle right there, which is angle Z, and which is 151 degrees. Now, if you got to this answer, you were successful. If you did it a different way, it doesn't matter, okay? Because there are many different ways to solve these problems. Okay, let's go ahead and finish up this this lesson with the last exercise, exercise 4. Two lines meet at the common vertex of two rays, a big mass of lines down there. Go ahead and set up and solve the equation to find the value of x, and then find the measurement of both GAF and BAC. Okay, with no further instruction, I'll have you pause and get to it and come on back and check in. Okay, let's go ahead and solve this this last exercise. Okay, so I'm going to look at that line there, and I am going to be looking at angles on a line again, and we know what angles on a line add up to. They add up to 180 degrees. Okay, so what I do know is I know a few things. Well, what I don't know is I don't know the measurement of this angle here, okay, because it's totally blank. But what I do know though that this angle, this angle, right, this whole angle here, okay, is 90 degrees. All right, now 4x, as you can see, is going to be less than 90 degrees because it only makes up a portion of that 90-degree angle. So I know that, and I know I have 36-degree angle here. So I know all of that has to equal up to 180. So I'm going to go ahead and name that angle, that unknown angle there, y, because I can do that, because I want to try to figure out what it is. I want to solve for it. Therefore, I want to give it an unknown, or I want to give it a variable, and therefore I'm going to call it y. Okay. So I know that y plus 90 plus 36 needs to equal up to 180. Okay, again, using my angles on a line relevant relationship. Okay, and just go ahead and continue. Y plus 126 equals 180. Y equals 54. Okay, so now I have y equaling 54 right there. Okay, so I know that. Now, I see another line that I'd like to work with. Okay, so I'm going to go ahead and erase all of this. I'll just try to keep my 54 in there. Okay, because it's going to be helpful. All right, and I see another line. Here's another line right here. If I can take that line. So now I have, again, another situation where I have angles on a line. All right, but these angles now have, two of them have the variable x in them, and that's 5x and 4x, which is very convenient. So all I need to do is put that together. I have 5x plus 4x plus our newly found 54 degrees equals 180. Okay, 180 degrees, right? And we know this is angles on a line, so let's get rid of that. Okay, so there we go. You know what to do. 9x plus 54 equals 180. 9x equals 126. Is that right? 126. And if we go ahead and final step, 1 over 9 times both, and that's going to give us x equals 14. Okay, so x equals 14 degrees right there. Okay, all right, so if our x equals 14 degrees, we can then use that to help us solve the problems that they've set before us here, and that is to find the measurement of GAF. Okay, so let's find GAF. Okay, so if GAF is 4x, you know what to do. 4 times that 14 is going to give us 56 degrees. Okay, so we have GAF as being 56 degrees. Okay, just by plugging in our x. And the next one they wanted us to find was, of course, BAC, which is 5x. And then if we multiply 5 times 14, we get 70 degrees. All right? So there we go. We have solved for both of those. Oops, not 56, but 70 degrees. Okay. Alrighty, here we go. Lesson summary. This was the last one. Lots of fun. I'm sure you had fun. Somebody out there must have as much fun as me. Anyway, so steps for solving unknown angles, like we've been talking about. And again, good practice. I hope you've enjoyed this practice. You identified that angle relationship. We saw some supplementary angles here. We saw some complementary angles. Lots of vertical angle use. Angles on a line seems to be a very popular one. Comes up, easy to use. When you identify those relationships, you set up an equation that will yield the unknown value. You solve the equation for the unknown value. Substitute the answer, determine the angles, and then check to verify by measuring the angle with a protractor. And I'm not sure if you did any of that. I have not been, but if you are, that is very fine, and fine indeed. Okay? All right, well, I hope you enjoyed this, and that's the end of this topic. Topic A. Topic B begins, and what we'll be talking about triangles. Okay, we'll be delving into triangles to start topic B. All right, good luck on your problem sets.